Hi, everyone. Thanks for joining. We're going to be reviewing a computationally stressful piece of work that's a real business need, and it surfaced a couple of years ago. We needed to meet a contractual deliverable of how many IP addresses were correctly situated within prescribed IP ranges. I'm going to provide three different approaches here. This is approximately similar to what was actually used in delivering the result to the client. This particular version will go through about 450 million iterations. The assumption here is that you all have either Excel 2016 or 19 installed, modern Excel with the Power Pivot capability, and or you've got Power BI. You're an above average Excel user, and you're willing to experiment with M and some DAX code, and most importantly, Power BI. So the lesson plan here is we're going to review the presenting problem. We're going to solve the issue with Excel's most versatile function, which in my view is some product. Then we're going to examine the data model, and then we're going to go to DAX Studio and develop some DAX. Then we're going to apply the expression to DAX query, and we'll talk about what that is. And then we'll shift into Power BI to see the dramatic difference. In the course of doing this, we're going to compare and contrast response times from the three approaches. And then we'll come back and talk about our conclusions. So you can see here, just to explain the problem in very basic terms, we have a range. Now, this is not an IP range, obviously. This is the decimal. These are decimal values. You'd have to convert the IP values into their decimal equivalent ranges. That's not really germane to the issue. It's a complexity that's not material. So what we have here is a decimal value that we need to situate inside a range at the same time that we're identifying, we're going to connect the tower designator and the region designator to what's in the lookup table. So we're matching multiple criteria here, which is easy to do, but locating the number inside of a range and doing it all concurrently, that's something new. So let me get rid of these let me get rid of this whole thing. So step one, give ourselves a bit of room. So step one is to start with our sum product function. And we're going to avail ourselves of a neat trick involving array capability. So we're going to take this number we're going to basically take this number and we're going to evaluate it relative to the start column. So the user relative to the start, right? So that's number one. And then we're going to insert the Boolean AND. So we've got a set of AND concatenations for the first array. Okay, so the user number now is less than or equal to the number. Close it off, do the concatenation. So now we want to take the tower designator and we want to locate it within this column. Close that off, concatenate, and we now go to our final, pick up our region and situate it inside this column. And now we can close it off. All right, so we have a series of ones and zeros. What does that mean? It means we have a hit, but now we need the row number, right? And we need the row number because we want to do a lookup on the site ID. Well, now we avail ourselves of the second array, and for that we're going to use a match statement, and we're going to take this inside of this, and we'll run that. You can see for the first couple here, so this is row 7, so that worked out nicely. So now let's go pick up our VLOOKUP. So now we need our table array, which is the lookup table. Now we need our column index, which is number 6, an exact match, and close it off. Okay, well now we'll fix this with if NA, open that up, give ourselves a blank. Okay, so that works fine. So now let's do okay, that's quite an improvement. I've got 1 minute 42 seconds here. A little different than before, but 1.5 minutes, 1 minute 20, 1.5 minutes, I've observed to be pretty typical. This is substantially better than what I'm used to, which is 15 and 20 minutes with this calculation. So the hardware has had an effect. Very good. Okay, we've solved the Excel problem now. Let's just go to the next phase, which is we want to examine the data model. The point of looking at this is to highlight essentially one fact, which is these tables are unlinked. There really is no way to connect these things. The index number is not a valid connection, although it is a potential basis for a connection. it's really not valid in generating a pivot. This index is there as a data model artifact. So the index values, although they would ostensibly connect, they really don't serve any purpose. And so we really can't use them in our calculation. So these are essentially disconnected tables, and the point of making this the point of bringing this up is to indicate that the DAX that's constructed needs to function with disconnected tables. Okay, let's go look at DAX Studio. Refresh our data. You see the tables here resident in the model and a series of functions that are available to us. These expressions are abstracted from here, and they'll illustrate the path that we're going to follow. So we start this with an evaluate statement, and you can see what we're trying to replicate here, right? Is we need to take our basic table. If we run that, you can see, notice how fast this ran. This is a 30,000 row table. You can see here 30,000 rows. We ran it within perhaps a second response time. Let's actually to check that. It's actually 590 milliseconds. It's actually quite astonishing. It's great stuff. So the function we're going to start with here is our add columns. It's asking for a table. We have our table. The next item is an expression. So we'll use a little bit of keyboard magic here to do that. Because we have disconnected tables, we need calculate. We want to iterate through the user table row by row with calculate. And so now we need it's a little bit of a tricky function, but what we're going to generate with this is a one-column table that's going to generate a set of unique values. And so for that, we're going to look at our site ID. Now we need to generate, the next piece is look at the calculate. We've got our expression. We're looking at the values as the expression. We need to filter it. We're filtering our lookup table. We're going to take our number from the user table, and we're going to evaluate it relative to the start. Number from the user table to the finish, lookup finish. You see the pattern? Very similar to what happened, what we did with our subproduct calculation. Similarly with region, close the filter, close the calculate, close the add columns. Unbelievable, first time. Take a look at the, okay, so that took 1.6 seconds, and most of that, let's do that, run that again. So you can see most of that's in the formula engine. We're not really running very much on the storage side. Most of it's on the formula side. Okay, so now we're going to take all of this, including the evaluate piece. Okay, we're going to copy it. And now we're going to go to our DAX query. And let's just remove this. So recall, because we are connected to a table through our connections, we now have the ability to edit our DAX. You can see we've got some DAX in here already. We'll just take it and copy over it. So we basically copy-pasted this from our DAX Studio. And let's hit run. Okay, that took roughly 47 seconds. A little bit of an improvement over some product. So you can see what we're doing here, right, is we're materializing in a way on the sheet something that does not exist in the data model. Okay, so this doesn't exist in the data model. So we've materialized something through our DAX expression onto the sheet by availing ourselves of the scripting in DAX Studio, and we've materialized something, a new table that we could actually bring up into the data model as a new table, and it's not confusing. It will sort it out. So this can be a very interesting and a very powerful feature. Next, we're going to go to Power BI. I'm going to bring up the file. You can see we've opened here to the file with the notes in it. Very quickly, you can see here, this is the data model side. We did avail ourselves of one little Power BI trick. You can see we have a source table here, and then lookup and user. On the source side, what we're doing is, you can see we're going and we're picking up the user file directly, and we're ingesting a piece of that. Then when we go to the lookup file, we're linking into the source, and we're basically downloading the files. And the reason for that is we only hit the source file once. And what that enables is caching to occur in the background. And you'll see the results of that caching here in a minute. Right, so here's a completed solution. But what I want to illustrate is, you can see this is the calculated column, and it's consistent with what we saw previously in in DAX Studio. But let's do this. Let's go pick up, instead of the site ID, let's pick up the index value and hit OK. I'd like to point out that's a sub-second response time on 30,000 rows, 450 million iterations. And you can see the effect of the caching and the engineering that is in place with the Power BI capability. Let's go back to our site ID. This is real time. I'm not cutting any of this out. There it is again. In fact, if anything, it was a little faster. So sub-second response time, really quite exceptional. Let's go back to our conclusions now. The most important conclusion here is that Power BI is the business intelligence tool of choice. Capabilities, according to Gartner, are accelerating versus Tableau. You saw the exceptional response time on the data set. And the limitation here with some product is not only does it take a little longer, but it does require, through the match function, an independent key number one, and it requires VLOOKUP in here number two, because VLOOKUP essentially is conducting a search of the entire table, which tends to slow you down a little bit. So while some product is great tool, it's the most versatile function, Excel's a great tool, and all the rest of it, you can see the limitations of associated with scaling into enterprise grade issues that require simply better tools to deal with. Okay, everyone. Thanks a lot, and give me a buzz if there are any questions or comments.